So having looked at the first factor, which was the position of the ion in the electrochemical series, we can as well look at the second factor, the nature of the electrodes. The first experiment under this is electrolysis of copper to sulphate using copper electrodes. We can look at the setup of the experiment. The setup looks like this. So we can as well try to label our experiment, our setup. We have this side, we have the cathode connected to the negative terminal. We have the anode connected to the positive terminal. We have our battery. We have our solution, copper to sulphate. Have our solution, copper to sulphate solution. So we can continue with our experiment saying that in solution, so in this solution of copper to sulphate, what we have, so ions present, the ions present, we have copper to sulphate, aqueous, it will ionize to give us the copper to ions and the sulphate ions, also aqueous. Due to the presence of the copper to ions and in the solution, this solution is blue in color. So we have a blue solution here in our beaker. Then we have water, aqueous, also ionizing to give us hydrogen ions, aqueous, plus the hydroxyl ions, also aqueous. So we discover that in this solution we have two ions, two cations and two anions of different nature. So we have the copper to ions and the hydrogen ions, then the sulfate ions and the hydroxyl ions as our anions. But remember, this time round we are using cathode, a copper cathode. At the same time anode, using a copper anode. The electrodes have changed from graphite electrodes to copper electrodes. To the cathode, so the cathode, this is our cathode, being that it is a negative terminal, of course the positive ions will migrate to the cathode. So what we have at the cathode shall have both copper to ions, we have copper to ions, and the hydrogen ions will migrate to the cathode. So have copper to ions and hydrogen ions migrating to the cathode. But copper ions are discharged in preference. Copper ions are discharged in preference to the hydrogen ions. Why? Because from our reactivity series we discovered that copper ions are below hydrogen ions in the reactivity series, or they are less reactive than hydrogen ions. So we have copper to ions being discharged in aqueous to form, they are discharged by gaining electrons to form copper solid. At the end of it all, we are going to see a brown coating, around the negative terminal. I'm trying to shade here to show you that we are going to see a brown coating around the terminal. So the anode will increase in mass. Then secondly, the anode, the positive terminal, we have again two ions. We have the sulfate ions in solution, then we have the hydroxyl ions. So both hydroxyl ions and sulfate ions migrate to the anode, but none of them, so none of the ions is discharged. Instead, the copper anode will go into solution, and that is called electrode ionization. The copper anode will dissolve in solution, forming copper ions to replace the copper ions that have been used up in the solution. So we shall have a decrease in mass. So this side, I'm trying to paint show that the copper anode loses mass. So at the end of the experiment, we shall see the copper anode losing mass and becoming smaller. So the equation at the anode will be copper solid will lose its electrons to become copper 2 ions. So it loses 2 electrons to become copper 2 ions. This is aqueous. But I told you before that it is not right to write a negative sign into the equation. So write copper solid forming copper 2 ions, then plus electrons, 2 of them. So this is the equation at the anode. The equation at the cathode is this one here. From these two equations, this is number 1, this is number 2, we can write the overall equation. Overall equation can be given by adding equation 1 plus equation 2. So we have copper 2 ions aqueous plus 2 electrons, then plus copper solid, giving us this side we have copper 2 ions plus copper solid, then plus 2 electrons. So you can cancel out what is common both sides. You have 2 electrons common this side, then that side, and then we write our final equation as copper 2 ions aqueous plus copper solid, giving us copper 2 ions aqueous, then plus copper solid. That is our final equation, as simple as that. So this is